Okay, welcome to day one of Advent of Code. This is me live solving. I haven't looked at the questions at all, so first time reading it. Let's go. TLs have good news and bad news. The good news is that they've discovered product management. This has given them the tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that the other critical tasks can start on time. Bad news is that they've realized they have different emergency. They have a different emergency according to their resource finding. None of them have any time left to decorate the North Pole. Save the Christmas elves. You need to finish decorating the North Pole by December 12th. Collect stars by solving the puzzle. Two puzzles will be made available each day. The second puzzle is unlocked. You complete the first. Each puzzle grants 1 star. Good luck. You arrive at the secret entrance to the North Pole. Base ready to start decorating. Unfortunately, the password seems to be changed, so you can't get in. A document taped to the wall helpfully explains due to new security protocols, the password is locked and safe below. Please see the attached document. Receiver has the dial with an arrow on it. An arrow around the dial are the numbers 0 to 99 in order. You turn the dial, it makes a small click noise as it reaches each number. Attached document, your puzzle, contains a sequence of rotations, 1 per line, which tell you how to open the safe. The rotation starts with L or R, which indicates whether the rotation should be left towards the lower number or right towards the higher number. Then the rotation has distance value, which is indicating how many clicks the dial should rotate in that direction. So if the dial we're pointing at 11, a rotation of R8 would cause the dial to 8 clicks. Okay, so 11 plus 8 to point at 19. After that, the rotation of L19 would cause it to go back to 8. Okay. Because the dial is a circle, turning left from 0 1 click makes the point right. Similarly, no, okay, circular. So if the dial were pointing at 5, the rotation of L10 would cause it to point at 95. After that, the rotation of R5 starts at it's at 50. How could you could follow the instructions, but the recent Like your recent recording show most for secret and engine security trainings has taught you that the safe is actually a decoy. The actual password is the number of times the dial is. The actual password is the number of times the dial is left pointing at 0 after any rotation in the cycle. For example, so this is a weird sentence. The number of times the dial is left point. Oh, okay, wait. Let me see. For example, suppose that the attached document contains the following rotations: L68, L30, R48, whatever. The following rotations would cause the dial to move as follows: 82. Wait, calculator. 50 plus 68 minus, I think it was 99, 19, then, or 60, 99 minus 50, there's 45, 30, okay. 82, then the dial rotated at L30, went at, then after that 52 is 30, then dial is rotated at 25, R48, went at 0. Oh, Because the dial's position at 0, position points at 0 a total of 3 times during this process. The password in this example is 3. Analyze the rotation of your attached document. Oh, the password is 3 because it's 0. Oh, that's a weird way. The number of times the dial is left pointing at 0 after rotations. Oh, that's some way of saying it. Okay, because the dial points to 0 to 3 times during the process of measure. Analyze the door rotation attachment. Okay, let's take this. Let's reason through it first, and then we'll write the code. Let's turn it to white. Okay, so we have a number line. 0. Oh, 0. 1 second. Let me take my mouse into mouse. Okay. Okay, so we have number line 0, 99, and then 50. You go like this, you wrap backwards. The password is the number of times after each rotation. If we hit a 0, that's 1. If we hit another 0, then it becomes 2. So on. I think it's pretty straightforward. But the only tricky thing might be rotation. So if you're at 0 and you do L5, um, we'll do -5. We'll put us at -5. And then we'll do absolute value of that, which will give us 5. And then I think if we do mod 100, obviously it'll give us 5, but it should go. Maybe not absolute value. Let's try go -5. Oh, okay, if it's a negative number, just do this. Oh yeah, okay, so if the number after any rotation is a negative number, then the formula to find its index, or the number we are on, is 100 mod, or 100 minus whatever index we're at, mod 100. Or, yeah, 100, yeah, because it could be, we might go all the way around, we might end up at like -120. -120 would be, so n 100 minus -120 mod 100 is 20, and this would be 80, because the 100 would wrap us back around, and then the 20 would put us at 80. And for positive numbers, I think it'd be the same. No, it'd be for positive numbers, it would be, n is positive, it would be 100 minus I mod, maybe not minus, plus 100. So if we're at 120, then that would be, we'd go right all the way in 100, then on the 20, 100 would take us all the way here, and 20 will bring us back here. So n equal 100 plus 20, or 120 mod 100. Yeah, you get the gist. Now, let's actually code it up. I have a document, but this is good enough. I'll write up the article sometime in the future. Uh, let's check its status. Uh, okay, so first we need to read the file. Let's make a util because I think we're going to use this every single time. Utils, utils, it's not a class but a file. Um, function, read, file, oops, file path, read, I think it's like this file path. I always forget it. I have it in the new window. It's a different project I have. But I don't know why I keep forgetting this line. Yeah, file path dot read text. Okay, read text. Oh, turn type. Uh, yeah. Okay, first we need to read. Let's change this to the input. Rename data at txt factor. If this is the example. This is an example. Okay, this is the puzzle input. Ooh, it's long. Let's use the example first. D1, and then input, go, delete, and copy path and source. Source, read that, and password that, and uh, it's okay if I have it like that. We have the input. Let's just look at what it looks like. So like that. Let's do this. Can we split a string? This is the part where we learn about content. So split. I want to split on every new line into an array. Yeah. But do I want to turn the left to negatives? Yeah. Oh, okay. So component string method split. Wait, I think it's just split. Yeah. Split. This is the two typed array. Answers is incorrect, but it's okay if it's a list. Sure. It's called moves input. Let's put new line characters and let's print. Let's just do your. Yeah, it's a list. Uh, this supposed to. Wait, I think lists. Wait. Um, I think they should put. Did I actually remove the new line? No, I don't think I did. Uh, oh, I should just put this learn X and Y minutes. Uh, string, strings, uh, templates. Okay, okay. Okay, contains. It moves, and that contains a new blanket. I think it's the new blanket. Then why is it printing it like this? Is it because it doesn't have space? We do slices. Slice. So, array. Uh, Conference slicing. Slice. Okay. That's slice 0 to 1. Or 0, not the 5. That's, oh, what happened? Okay. Great. Finish the first 4. This should work. See how big it is. It's only 1 long. Wait, has split only split the first one? With string into array. The fuck am I doing wrong? Is it just one? It's just one long string because it would have columns. Why is it not splitting? What is the? Is it? Wait, let me just check. New line character. Maybe that's what I'm doing. Oh, it's forward slash, not back. My bad. Okay. Okay, okay. So we have the moves. Now time to process them. we start at 50. So val of var I equal 50, and then for each move, we'll create a value called result var solved. I like res. Result is 50 for each, and in move we will. What will we do? Tell me. We will say, okay. So if can I index substring, right? Okay, substring. Oh, okay, so each move at okay, yeah, of leaving now indexing string. Oh, it's just you could use square brackets. Uh, if the first character is equal to just we'll do let's do right. If it's right, then I, the new index, I is equal to, there's our formula. This is right, so 100 plus the current index on 100. Actually, let me call this. Yeah. And then, so that's the index. Else, do minus. And then, it's never going to be negative because it's always mod 100. And mod 100 is always between 0 and 99. And then, if I is ever equal to 0, then there's increment that, and then at the end we will print the rest. What? Oh yeah, we use equals dot equals, I think. What? Returns a character. Oh, sorry. We'll use character instead of extra, and this will be extra bracket. What are you complaining about? Refactor, reformat that. What are you complaining about? Assignment can be lifted out of if. No, it can't. No, shut up, ID. Okay, we got something wrong. Let's step through it. 50, 82. So print the moves we have, print current index for moves, and uh, or just 5, then 1. Oh, sorry, not 100, but where the fuck did I get 100 plus? Uh, yeah, where the fuck did I get 100 plus that? It's I plus whatever you. Yeah, it's I. N is equal to I. Oh, what did I say? 100 plus I on 100. Yeah, because it wraps around if it's minus. Okay, let's say you're at 0 and it's minus 20. Oh, wait. Back to the drawing board. I think going right is easy. So you're at a certain index, you add whatever new increment you have, and you just do mod 100 just so you don't go over. Yeah. Oh shit. Yeah. This is we go right. We go left. We're at an index. We're trying to move in the opposite direction. But to make sure we don't, maybe have to hard code logic in for if it's negative. That will be clean though. Um, okay, we move left. If it goes below 0, you just do 100 minus that. Or let's go back to the number one. Let's do 0 to 10 for simplicity. We're at 0. We'll do minus 5 or minus 2. You give us negatives 2. Yeah. Let me just double check. What? That's not modular. Okay, I guess then we have our formula. Uh, no. Or maybe you just add it and you mod it. Yeah, sorry, my bad. Okay. Let's do actual examples. Stop theory crafting. Okay. So if we're at 0 and we have a minus 2, that's just, let's go back to 0 plus 3, or 0 minus 2 mod 10. And then if we're going over on the right side, we do 0, or uh, actually not 10, but 9 plus 2 mod 10. This should 1. Yeah. Oh, pretty clean. Wrong formula. Right. That's what I get for not using examples. Okay, so the current index we're at plus the uh, the move turned into a let's do uh, offset, let's call it, or offset equal to m dot substring starting at 1 Yeah, I think if I just give it do 2 then I plus the offset mod 100. And I think we just will say we can make it more clear by doing this. And then depending on this, we'll say offset times cool minus 1 or nothing or yeah, actually way more clear. Offset is negative if it's left. Yeah, let's see. Still 0. Let's step through it, I guess. Mm, uh, no, oh yeah, I see. No, no, no. Offset, um, I set 100, '68. It was left example. 68 left. Why didn't they subtract? Oh, capital L. Oh my god. Yeah, I got it right. Right here. Ready? Let's get our puzzle input. Uh, boom, boom. Let's stop printing. Oh, let's. Oh, what happened now? Oh, file. No. Are they empty? Range 1 to 0 out of bounds. What line? Let's do this. Try. Uh, Catch whatever goes. Pressure. Code debug. And we're doing well. Mm, mm. Yeah, this is the new number. What? When are we ever getting it empty? Is there just a line? There's. Okay, we have to make some. guarantees. We'll just do this then. Uh, uh, ah, okay. So before we do that, we have to make sure if add size length is less than, it has to be at least 2. So less if it's less than 2, then how do you skip? Skip an iteration of a loop. Oh, I can just skip. Oh no, that was the question. If you're interested in something, no, there's no skip. Oh, continue. Same as jump. Yeah, same as jump. 159. Let's see. Admit. That's right. You have one gold star closer to. Okay, let's go to part 2. That took too long, dude. How long have it been? Wait. That took what? 30? What? Jesus, I'm cooked. Okay, part 2. First time the puzzle is complete, it provides a gold star. You're sure that's the right password? If the door won't open, you knock, and nobody answers. Build the snowman while you think as you're rolling the snowball. For your snowman, you find another security document that must have fallen into the snow. Due to the newer security protocols, please use password method OX that looks like hex until further notice. You remember from the training seminar that the method means that you're actually supposed to count the number of times any click causes the dial to point. Any click causes the, regardless of whether it happens during rotation or, ah, jeez, this is, okay, following the same rotation as the above, the dial points at 0 a few extra times during the rotation. Dial starts at point 50, the dial rotates around during the rotation, the area is well, and then it gets to 0. And this is going to point at 0 3 times at the end of the rotation, plus 3 more times during the rotation. So, in this example, my password would be 6. Be careful with the dial pointing 50 at a single rotation. Now, we don't want to count. We have to find, let's do a new formula. New formula, new formula, new formula. Okay. Oh, we're basically asking how many multiples of 100. No, not multiples of 100. No. Don't jump to the conclusion, man. So let's say we're at 4 and we do plus 4. No, we do, let's say minus 6. So we go, let's make this number line bigger. Okay, so we got did, cheese, 9, 10. Okay. Okay. So we say at 4, let's do a, let's do a minus 8. So we go here, 1, 2, 3. 4, 5, 6, 7, 8. Yep. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Um, quickly check. White and pivot. Uh, 4 minus 8. Let's just do it. Nope. 1, 2, 3, 4, 5. Going to 10. 6, 7, 8. Or do we not count this? Oh, geez. No, 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 no. Wait, that's wrong. That's wrong. It should be 0 to 9. That's right. My bad. My bad. My bad. Okay, then yeah, it makes sense. Then it's 6. Okay. So yeah, 6. Okay. And then how many? So in this, okay. So if we add a point in the number line, add 4, and we add 8, well, obviously, we'll hit 0 at least once. The reason is, dude, I should change mics. Right, that's it. So, but the reason is 4 plus 8 is equal to 12, and there's a 10 in there. So if you, the reason we have a mod is just to bring us back, but there's at least one 10 in here. So 12 remainder or division by 10. There's one remainder 2. So I think quotient? Yeah, remainder, quotient. Yeah, quotient, yeah. So 1,000, or if we did, yeah, in the thing it says 1,000 10 times because 1,000 divided by 100. Yeah. Okay, but in your previous code, you were. Or I think we can still change it and get the same result. We can do, instead of doing offset greater than on the never, we'll just do I plus offset, or I plus equal offset, and then if I is greater than 100, then the new I equal to 100. or I want 100, right, 100. Um, but no, I don't think that works. No, I don't think that works. Uh, let's just keep the logic as it is. I don't think it's that much. We just have to count how much in between. Okay, for the in betweens, let's put this guy down as well. In betweens, let's just do total displacement or distance. This. So this, obviously we start at 50. But if this plus the offset, the amount of zeros we encounter is going to be this 100. Uh, integer. I think if they're both integers, will be integer division. Don't have to specify. So, huh. So let's go back to the example. So calculator uh, 50 plus 68 divided by 100. That's 1. So hit there once. Then we're at 30. And 30 plus 52. Oh, sorry. Oh, sorry. 82 minus 30. 52. And then 52 plus 48. There's 100 there. Okay. So the additional is just this. The additional distance for the additional numbers is just the current number. You want the sign, the correct sign for offset. So next, we go to current number, plus the offset, and then we'll do if whatever this returns is then divided by 100. And if that is greater, yeah, I think it would just be integer division. I don't even have to do greater to check. And then that, and then whereas a plus, and then yeah, and each time I think we do plus yeah, distance to travel. And for the first one, let's do the sample input. Maybe that empty space was from should be 3. Huh? I didn't even change much. Oh, But it hits it on the back way. So that's why, okay. Divided by 100, and then otherwise this is just 0. And yeah, let's see. 5. Is that the number? I think it was 6. This sucks. Because when you're wrapping back, at least going forward, it's easy. It's just adding. Or is it? Yeah, it's just how much distance have you traveled so far? So 30? If you're at 30 and you do plus 51, there's still going to be divisible. There's going to be, you're going to hit 0 at least once because you're going to get to 100. And is that what I did? Yeah. And I is never negative. Let's see the index I'm getting these at. So print and then I or I is that and I or the move. I did wrong the move. What is that? I'm only getting it L68 and L55. L68, L50. Well, maybe I'm double counting. Or I don't know if I'm double counting, but just wait. The down starts point at 50, down starts at L68, point to 82 during this rotation here. Yeah. The down starts at 52, right 48 points at 0 points. That's the point. But with my right, yeah, 52 plus 48. Infantry division by 100. It's oh, that's a bog. That's a bog. Oh, but I'm doing greater than 100. No, I'm doing greater than 100. I think then great. Then rotates at L52.2. Let's also print what moves I'm getting right for this. So yeah, let's do points. So the points are 48, 55, 99. Point 48, 55, 99. I'm getting the points correct, but the 50 and 55, or no, 68 and 55, 68 and huh? Okay, maybe the last one I'm just no, I'm not getting. How is it? Okay, I'm gonna start printing it. 68, 55, I 55. I never looked in. When does it ever add 55? Okay, add 55, but it should be R60 then. Let's also get the index. Index. How are we getting? Oh, I see, I see. It's because I don't do the distinction of. Because if you're at 55, oh, I see, I see, I see, I see. If you're at 55 and if you don't do the offset sign change, you do 55, you do 10. I think you'll get one, but then which wait, but is that wrong? Wait. I don't. I only update it like that, which is correct. And I don't change the value of offset. Okay, let's just have a print for each time. We're at that current index. We'd like to perform that move. Okay, we'll go in sequence, lead in the index. The distance being calculated will be that, and then we'll just do the check when we read it. And then let's also print our new index like that. Call it next, and stop. Yeah. Okay, we're at 15. The next is 18. Oh, let's do it after we do the sign change. Oh, I see. There was just something wrong with the way I was doing it before. But I have to actually write the code to check for to do the wraparound instead of doing this weird modular thing. Okay, so we're gonna actually say, um, okay, up to this point, let's forget the dist. But up to this point, to this point, we this point, we have everything correct. Then this is what we're gonna do. We say we just add the offset to that to I. Then if the offset we just added, or we'll just say I equal that, we'll just go to that. And then after we added that, if I is, let's say, below 0, then we'll do I is equal to 100 plus whatever the minus side is. In the other case, then if it's greater, or else if I is greater than 100, we've overshot, we'll just do I is equal to uh, the new overshot number, we'll add 100. Why is my ID saying warning? I don't want to do that. I like it explicit. And then if I is ever equal to 0, we get, yeah, sorry. Yeah, why am I getting 2 then? I is less than 100. Eighty-two. Let's just go back there. 82, 52. Um, blueprint. Value. 82, 52. Okay. I was going to only really very little. But regardless, we got that. Now, oh, then every time. I don't know why I'm being so, so overly complex. But, uh, let's see you're at negative 200 or negative 201. See, you start at 15. Or let's do, you do 15, 50. Let's write it down. You start at 50. I do a minus 50, you're at 0. Then you do a minus 100 or minus 101. Then you're at negative 1. Or just, sorry, 1. We're at 1. And then I do a minus 100. Then you're at 1 again. But we've passed 0 twice here. And if anytime you so minus 201. Okay. Great. Let's just do complement is alias. I'm sorry. The number 9. Why did it print 20? Oh, sorry. That's a mistake. Dude, how long are we spent? An hour. Jeez. Okay. What am I missing? I don't want to manually count. I mean, that'd be the straightforward solution. But when you go backwards, you pass 0 if what's there? What has that be the case? Well, you see, oh, yeah, take out my headphones out. Um, you pass 0. Jesus, my brain is fried. That's what I get for doing it after work. Excuses, excuses, excuses. Uh, let's do this with 9. And we're at 3. And then let's do it. Let's say we do -5. That's a 1, 2, 3, 4, 5. We're at 8. Okay, so 3. We're at 3. We moved 5 steps. That's it might have been to the left, but it's 5 steps nonetheless. And when you move 5 steps in this process, you get wait, did I count correctly? 1, 2, 3, 4, 5. Yeah. Yeah. 5 steps. You've traveled a total 8 steps. Or in total throughout this passing. And we've passed 8 once now. How do we know we've passed 0 once? Well, I don't want to count, dude. I don't want to manually count. There has to be a better way. What if we fuck the number line, man? We can do everything on a fuck the circle. Sorry, that's what I meant. Let's do just one straight fucking, just a continual number line, and we're at 0. I'm not gonna do the arrows. 5, 6, 7, 8, 9, 10, 12. Then, the negatives. 1, and so on. So if we did, as you said, a left move, oh, shit. A left move of 5, end up 1, 2, 3, 4, 5. And then let's check. I think that does work. So if you did -2 mod 10, which is the number line we're trying to confine it to, you get 8. And ooh, maybe something to do with the remainders, because or divisibles. Uh, so how do you know you've passed 0 now? I guess maybe that's right. The remainders below. The remain so 1, 2, 3, 6, yeah, maybe the opposite. I guess small, 9, 6, 5, so on. So we move. The remainders. Dude, this can't be an n-square algorithm. Can. Yeah. No, I don't want this to be n square. For the record, there's like a straightforward double for loop solution to this. I don't want to use that because that's n square and not O of n. You know, this good, this bad. uh, there has to be a simple thing about it. You passed 0 because oh maybe cumulative sums or something about that. Ooh. Ooh, I didn't. Interesting. Oh, okay. So if the distance you've traveled would lead you in a remainder that's in your range, so you could say, okay, well, I haven't crossed, but you could say, okay, I'm at remainder 3. I do plus 5. I should end up at remainder 8, but my my sign is different. Or if I do, maybe let's do, wait, kind of stupid. Let's do small. Let's do 4. Let's do 4. Let's do range of 4. Let's do that. Let's do 0, 0, 1, 2, 3, 4, 7, 8. Look at that boxes. 7, 8, 9, no. 3 minus 1 minus 2 minus 3 4 minus 5 minus 6. Um, so we're here. So, 0, 1, 2, 3, 0, 2, 3, 0, 1, 2. Okay, so, I think it'd be opposite. Let me just double check. Yeah, 3, 2, 1, 3, oh, 3, 2, 1, 0, 2, 1. Okay, I might abandon the number line thing, but keep the remainder thing. Let's just see if there's a pattern here. So if we're at, say we're at 2, and we do minus 3, then we go 1, 2, 3. It's not going to change the dead giveaway, but 3. Oh shit, if your increment is always, yeah, I was on the right path. If your current position plus the increment. Because if you're here, the only increments that still mean you don't ever pass a 0 is plus 1 or minus 1. You could either go, let's do a different color. If you could either go minus 1 or plus 1, and you'd still be in the range. So, so, so we're at index, this would be 2, 2. And then if we move to whatever, plus whatever increment. In our case, we did 1, 2, do 3, or minus 3, minus 3. We moved out. But what does that actually mean in numbers? So that means your index plus the offset you're moving is greater than the size or the set of, or how many remainders there are. There are only No, we're not, dude. You got yourself mixed up. You really care about this zero. How do you know it crossed? No, but you do care about those because yeah, those zeros they do show up. They do show up. Sorry, we care about those zeros. Each time we cross that, it's touching a zero in the question format. So whenever your index plus your offset set is greater than the size of remainders. So if there's possible remainders, that size you cross a zero. How many times you cross a zero is however large this is and how many or like divided by the uh in our case four, but whatever number is, so let's call it Q. So yeah. Okay. So let's let's just remove all mentions of this. Let's compute it down here. Because everything up to that point is A-OK. And then so what we're actually asking is if the current index I'm at plus whatever offset I'm going to move to is the size of that is greater than the number of remainders, which in our case is 100, then that divided by the actual number, Q 100, is how many times we cross zero. Let's double check this. So like there's a here. So we were at 50, we did 68. We've index plus the absolute value of our offset, 118 is greater than the size of the remainder, which is 100. And how many times do we cross it? It's 118 integer division by 100, which is we crossed it once. Double check for the case that we don't cross it, which is we're at 82, 82, and then we move. Let's do absolute value. Oh, plus 30. I think it will be greater. 112. Fuck, I didn't consider that. So wait, why absolute value though? Let's just do non-absolute value. It works for right now. I don't know if it applies generally, but and let's go back to it. So 50 minus 68, 18. What would we have had? Ah, it would have been less than 0. 82. Oh, maybe it's just, dude, maybe I'm overcomplicating it. Anytime you wrap, you cross 0. Dude, I'm so fucking dumb. Oh my god. Anytime you wrap, you cross 0. So anytime the new index is, anytime they're not increasing, but okay. Okay, if the offset is negative and the new index is uh, the new index is if the offset is negative and the new index is greater than the old index, then we've crossed. If the offset is positive and the new index is less than the old index, then we've crossed. So we can do it. Dude, I'm so regarded. It's crazy. It's crazy. It's crazy. It's crazy. Okay. Uh, so if the let's just do new index. New I is equal to I. We'll set it. We'll set it. We'll set it later. Or let's just keep track of old I. Old I. Old I. Uh, anytime the so if offset less than zero, or that means if it's a negative number, and the the I, the new I, greater than old I, then we've crossed. We'll do cross. Let's call it cross instead of dist. That's horrible name. I don't know why you're over, over philosophizing. I don't know. It was simple. Think simple, dude. Uh, increase. In the case that else if 0 and uh, so the new I is actually less than old I. Cross process. And then we just increment the cross. Dude, if this doesn't work, I have to go to bed. We'll figure it out tomorrow. What? 9. You reset cross each time, right? Maybe don't count the cases where it is. Eh, I was double counting somewhere, but I don't know if I was doing. Oh my god. But that's way more simpler, and it makes sense. Where exit. So here we're at 50. We're going negative. Obviously this is 0. And the new index is greater than the old index. Let's do equal to. But that's just increasing the number. How many times did you cross? So just do this goddamn simple thing and let's move on. Let's not. I have to go to bed, man. I have to go to bed. I have so many things to do. Let's just do the simple thing. Let's do this. Let's count the crosses like. Uh, okay. Four. We start the over all the way up to. Wait, let me just quickly check. There's probably a cleaner solution. I'm missing. I know. We'll figure it out. That's supposed to be for the blog. For loops. For loops. Okay, for alright. Um Concept. Already up. Let's just let's make it cleaner. Start from the top. Let's have one cohesive solution. Uh, for the current index. I then I or G and offset 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 to int for that offset side. Let's make it double cost and equal alright, alright, and then we got below and then J for increment one and sine. Oh, we'll just increment the sign, sorry. I don't know why I'm doing too much. Then you increment it, and if I is equal to I is less than 0, you want to wrap back around, I is equal to 99, and then we'll have a cross counter, and cross 0. Alright, plus, and then plus. You can click the cross, and if I else, if sorry, I is greater than 99, then I is equal to 0 and cross. then to 1, and then by the end of the loop, if I is equal to 0, we also increment res, then I don't know why I'm doing cross. It also goes to res. Why am I doing cross? Nice. It's good to have. The amount of times I cross, the amount of time I don't have full die. Increment, if we cross, increment, if we cross, it's fast enough. Uh, or I should put it here. As long as ooh, sorry, my bad, my bad. Is it 9? Is that the answer? It's 6. It's 100, yeah. If you're 100, you're actually be a 0. What? Dude, what time is it even? 1 hour, 26 minutes. Dude. Oh. If how was it? How was cross 6? On L16, L48, what the fuck? And I have to make sure, okay, and J is not equal to, this isn't its last index. So this is for both, so we don't want to count it, but we still want to. Okay, J is not the last index. There's more to go. Maybe can go. Okay, much more reasonable. How are you having R48? R48. R48. 0. Didn't have the 'After L64, what is it? This is ugly. After L68, it's 82. After L30, it's 52. After R48, it's 0. After L5, it's 95. After R6, it's 55. After L55, it's 0. After L1, it's 99. After L99, 0. After, what? After L1, it's 99. And after L99, it's 0. And R14, it's 14. L82 is 32. It's such an annoying puzzle, man. Pass. You're supposed to pass on 68, 60, and 82. 68. How do you pass on? R48, 0, L5. Oh, if it starts there? Oh, because I think that it's off by one. I think that's the place where it's off by one. Oh, I pass. Fuck. Oh, I pass. R60 pass. That's correct. LED pass. Okay. If it's already the X is 0 and it moves left. Did you pass 0? I think you passed. Sorry. Pass 0 means you're either at -1 on this side, -1 on this side, or coming this way, you're at 1. No, or this way, you're at 99. You go right, you can get 100. Wouldn't it be anytime the sign changes? The sign of the actual number? Dude, I need. Okay, it's just logic for counting. Very simple. Let's do sit down. Sitting down or something. Sign of plus. To float. The sign is not equal to just Fine. Right? No. There's two cases, I guess. You go off the left or you go off the right. If you go off the left, if you're at if you're at 1, you do -2. Come back at 99. Dude, I'm brain dead. I plus. Yeah, anytime that's the case. Simple as, you know? Anytime what you already answer. If J is what? Let's fucking go. I did it. I did it. Mama, I did it. I did it. Probably not gonna work. What? What it do with your crew? It's me, Fight Crew. How many hours later? A whopping 2 hours. Let's hope it doesn't continue this way. Oh, my ear. Puzzling, but get your puzzling, but line up, everybody. Get your puzzle in play. I don't give a fuck if this isn't efficient. It's fucking works. We have fast computers. You know, who gives a shit? Tell me I'm wrong. If you tell me I'm wrong, I don't know what I will do with myself. Please, dude, please. Okay, I'm going to put down the headset. It's going to be quiet for a while. Okay. Well, crossed. I don't know if stuff is if we were the reason we want to check was not there. 6 to 8 4. What did I say? Too low. See if we get to the example. It's not expected. This is it was correct. But if I do less than 0,
Nice. Put then 0 is G. It's basically saying if we cross that this from 0 to 99, 99, 0, 0 to 99, 99, 0, then and from 0 to 99. Why would that be a cross? It's not a cross. Oh, why would that be a cross from 0 to 99? I just look like it. Alright. Yeah, it's but basically each time you hit it, you know, to but if it's not a cross, then you'll be left alone. So ooh, there's some original band that can't be put. Oh, no, 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 yeah. See. Yep. You, you, two, two, three, four, five, five, 16, 5, 6, 5, 0, 1, 9, 9, 0, 8, 2, 2. Okay. So we're calling the index is proper. Maybe, maybe, yeah, maybe, so, no, the same number. Yes, it's 2, it's 4, right? Same number. Let's try that. 1,000. The question is, please use the password of the phone. Three times. Saying that, let's go 3 first. 2. Is that logic wrong? Zero, zero. Zero's out. 6, 2, 4. Oh, really? What's this? We're already getting to it. Let's go! Oh my god. Okay. Okay. Okay, 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 okay. Lessons from today. After 2 hours and 22 minutes. Um, do the simple solution first, because, this is not leak code, this is solving the question. Second, make sure every line in your code makes sense, because, like, over here, I don't, like, I just assumed, I don't know where I got, like, if if you're on the first one, you can always move, like, every line should have me, like, there should know, like, for this one, it's like, okay, let's say we're at 0, and is that a pass? Yeah, let's say let's say we're at 99, and then we do a +1. Or, yeah, but we're just on our first iteration of moving that pointer, right? So, but we just crossed zero, so we're like not counting that. So like it has to be justified, or like it has to make sense. Obviously, it has to make sense. Fuck. Fuck. Okay. Time to commit this mother fudger. Yeah. Done. Day one complete. Click the push. Commit anyway. Push. Who gives a shit? Push. Yeah. I'm gonna upload the video. Okay. Catch me for day two. Hopefully, it doesn't take 2 hours.